what we're doing with Gibbs free energy so far is we're calculating the change in free energy at constant temperature and pressure, tapos yung number of moles ay hindi nagbabago, so constant din yon. That's why we normally calculate molar Gibbs free energy. But what if your Gibbs free energy is changing with respect to the number of moles? Ibig sabihin, paano kapag nagkakaroon ng change in composition? Okay? So, let me write that down. If pressure and temperature are constants, alright, but composition, and may kinalaman dyan syempre yung number of moles, composition is not constant, we can express or we can calculate, we are interested to calculate the change in Gibbs free energy as a function of the number of moles of a certain component I. And that will be again at constant pressure and temperature. And this slope, if you will, this relation or this term is equal to this quantity mu of the species I, and ito yung tinatawag natin na chemical potential. Okay? Again, basically, si chemical potential, it's the change in Gibbs free energy with respect to the change in the amount of the component. Now, kung meron tayong chemical potential, if the pressure will vary, so if pressure varies, you can calculate the chemical potential, okay, using this equation. So you will have a standard chemical potential plus RT ln of P over your reference or standard pressure. So this is what we did also before dun sa Gibbs free energy. It's just that we are now doing it for chemical potential. So, yung ating mu naught, again, I mention na yan yung tinatawag nating standard chemical potential. And the other terms here are familiar with you, okay, or to you, R and temperature of course. But for gases, okay, this equation is most applicable for gases. Yung ating P naught or yung standard pressure natin is equal to 1 bar. Okay, yan yung ating standard pressure for gases. And of course, hindi lang naman gases yung system natin, pa pwede ring solid, liquid, okay, or some kind of solution. So we need to define ano yung standard state for this substances, no? But before we get to that, kapag you wanna calculate the chemical potential of a certain gas, okay? So again, gagayahin lang natin yung equation dun sa taas. Plus RT ln. Now, normally, naka-express siya as P. Okay, or P sub I. So kapag nakita nyo siya na ganyan, it means, no, P sub I really means P sub I divided by the reference standard pressure. So just for your information. Now, pinag-uusapan natin kanina, what if you have other substances? So ano yung kanilang standard states? Okay, for solids, okay, ang kanyang standard state, so let me tabulate it like this. Standard state for solid is that yung solid mo dapat it's a pure substance and the pressure should be 1 bar. Okay, for liquids, ganun din. Dapat pure liquid and the pressure should be 1 bar. For gases, na discuss na natin kanina lang, dapat pure yung gas and 1 bar din yung ating pressure. Now, if you have solutions, or let's define it for your solute, dapat daw kapag sinabi nating standard state, ang molar concentration, which we will call C sub naught, okay, kanina pressure, no, but this time it's concentration, should be 1 mole per cubic decimeter. Okay? Now, generally, okay, so generally, how do we compute for the chemical potential? Okay, so mu I equals mu I naught plus RT ln of activity. So A here, let me just highlight this a bit. So this is your chemical potential, right? Pero ito yan yung general expression natin. Kasi kanina, what we have here is only for gases. Panggas lang yan. Kaya nga may pressure. Paano pag may solution ka or let's say reaction? How do you express yung Ln term? So, we will use what we call the activity of that species or substance. So, A refers to activity. Okay? Now, yung A na yan, pwede nating baguhin. Depende kung anong klaseng system meron ka. But generally, A dapat. Activity dapat. Now, if we have ideal systems, no? So for ideal systems, and we will define what ideal means. Okay? Let's say meron kang concentration. So, ano yung ibig sabihin ng ideal solution? Okay, ang ideal solution, it should follow Raoult's law. Okay, and we will talk about Raoult's law soon. But usually, kapag ideal solution, dilute yan. Okay, dilute. Right? And the activity for that, okay, for the solute, will be whatever its concentration divided by the standard concentration, which we define kanina as 1 mole per cubic decimeter. So, ibig sabihin, since 1 naman yung C naught, okay, the activity is just equal to the concentration. Again, that's only true for ideal solutions. Now, what about pure liquids and solids? So, ideal system tayo. Pure liquids and solids, okay? Ano yung magiging activity nila? So, yung activity will simply equate to unity. So, 1 lang yan. So, ibig sabihin, ang concentration ng isang condensed matter, condensed state, liquid or solid, okay, approximately equal to 1. That's why if you're going to calculate the equilibrium constant, hindi sila nagma-manifest or hindi sila makikita doon sa mathematical expression which is a ratio, right? Kasi naka-multiply na siya doon sa constant. Kasi constant din yan, which is equal to 1 kapag activity pinag-uusapan. Anyway, we'll get to that. But for perfect gases, okay, ideal gases, na pag-usapan natin ito kanina, right? But the activity of a certain gas is equal to yung kaninang term na pinakita natin, the partial pressure of that gas divided by the reference pressure or the standard pressure. Okay. Let's say we have a reaction. Okay. So, magkakaroon tayo ng reaction. Sabihin natin A forming B, a hypothetical reaction. Right? Now, alam natin na ang chemical potential is the change or the molar, the change in the Gibbs free energy, okay, with respect to the moles at constant pressure and temperature. So, yan yung chemical potential. And we are interested in calculating the chemical potential of a certain reaction system. Now, this partial derivative term here is basically what? It's basically the change in Gibbs free energy. Right? Molar nga lang kasi naka-per mole siya. Now, for this hypothetical reaction, if you want to calculate dG or change in the Gibbs free energy, okay, utilizing this expression right here, ito, So gusto natin kunin yung dg. So we will just separate the variables. So yung dg will be equal to mu times change in moles, right? So mathematically that will become mu of b dn minus mu of a dn. Okay, again from this relation. Now, yung dn dyan, okay, kung ano yung change in moles doon sa b, kasi of course nag-accumulate yung b, equivalent siya doon sa negative change in moles ng a. Okay, so pwede nating i-divide yung dg by dn. So ang lalabas is mu b, or the chemical potential of b minus the chemical potential of A. And remember, gaya ng sinabi natin kanina, equal yan sa reaction Gibbs free energy molar. Okay, ito siya. Okay? Now, how do you calculate or how do you express the reaction Gibbs free energy? So, ang gagawin mo lang, product minus reactant, pero you have to multiply by the coefficient. So, B mu B minus A mu A. Okay? And ang mangyayari dito is we can express this as what? B times, ano ba yung mu B? Di ba yun yung, if you're going to refer to this one here, eto siya, right? Okay, so we will express that for species B. So magiging mu B standard plus RT ln of the activity of B. Okay? Minus A, coefficient nung compound A, times the chemical potential standard of A plus RT ln of the activity of A. Ngayon, ang gagawin ko is I will rearrange this equation such that magsasama si B mu B standard minus A mu A standard plus RT, okay, I'm just collecting terms here, B ln of the activity of B minus A ln of the activity of A. But what is this part? This portion right here is what? Basically, ano yan? Yan ay yung Gibbs free energy at standard state. Okay? So, plus RT ln. So, this part now, this portion, you can express that, okay, invoking the loss of logarithm, magiging, since meron kang difference, A or activity of B divided by activity of A, and each should raise or should be raised to the coefficients B and A. And this ratio here, okay, we can use the symbol Q for it. So suma total, ang lalabas is that the Gibbs free energy is equal to the standard Gibbs free energy plus RT ln of Q, where Q is the ratio of the activities. Each is raised to the coefficient, and we call this, sorry, this should be A, and we call this reaction quotient. So this is now how would you calculate the change in free energy.